The company Ericsson is a very big, very well-known company for mobile technologies. And this year it is 130th anniversary of this company, so it has a huge history. And as you probably know, first international phone call was made using Ericsson equipment in 1950. And company is a pioneer and leader in GSM, in 3G, and now in LTE and other technologies for mobile network. In 2009, Ericsson runs the first commercial LTE network. It was the Ericsson equipment, and in the 1910 there was made a world bet for the speed of mobile networking. It was 90 and 84 megabits per second for mobile networking speed. It was a world record. So, no more buzz. Just let us invite our speaker, Carl Edwards, and welcome, Carl.
I have to tell you that I was in this building about 24 years ago. And outside looked about the same. Inside, of course, made much difference. But I'm glad to be back here in Ukraine. And today, as you mentioned, we're going to talk about big data. And what I want to do is not so much focus on the technical stuff, but more focus on business applications, and give you some real-life examples of how companies, how people, and even how you may in your home use big data technologies and applications in the future. So a little bit about my company. My company is part of Ericsson. It's called inCode, and we're a strategy consulting company. So we're part of Ericsson, and we work with telecom companies, we work with media companies, technology companies, and we're focused not just on what is the technology, but how can you apply the technology to your business. Now, our company's been around since 1998. I am based in the city of Atlanta, and I have been working the past couple of years with what we call cable companies. So I work with a company called, has anybody here ever heard of a company called Comcast? If you've heard of it, raise your hand. Okay, a few people. So right now I'm working with a company called telecommunications. And so they are, what they provide, they're a cable provider. So they provide cable TV, but they also provide internet. And one of the things that Cox is focused on is they want to provide 1 gigabit per second connectivity to somebody's house. Now, so you know what a megabit is, right? So what's a gigabit? It's 1,000 megabits, right? So here's a question. What would you do if you had to get a gigabit connection to your home? What things can you do you don't do now? What?
Download everything in the world.
Yeah, exactly. So you can, let me think about it. You can download a movie in about 3 seconds, right? So I'm actually going to show a video at the very end that it's called the Near Future Network. That gives you some ideas of applications, things you can potentially do if you get a gigabit to your house. But anyway, as I mentioned, we really help people figure out, okay, how do you take technology, how do you apply this to your business? How can you change the way you interact with your customers? How can you change the way that, how can you change the market with your technologies. This just tells a little more about some of the things we do. I won't go into this stuff much, but the goal here is to talk about, first of all, what is big data? And then I want to give you kind of a market overview. And then I want to talk about a little bit about the architecture. And then talk about how this market is evolving. And then I want to talk about two other things, which I think is probably the most important to you. What is the value in big data? How can I use big data? How can it change my life? How can it change how my company operates? How can it change what I'm able to do at home? And then finally, what may be most interesting for you is how do you build a career in big data? What jobs are there? And believe it or not, there's actually jobs here in Ukraine. In fact, I found some job postings where they're looking for people who have big data experience for jobs here in Ukraine. So what is big data? Who's heard that term before? Have you heard that term before? Raise your hand. Okay, so a lot of you have heard it. And people have used what we call in English, we call the 3 B's for this, trying to describe what big data is. The first one is just volume. And the whole idea here is that 10,000 times bigger than what we saw in the past in terms of the quantity of data. And what is this data? So I'll give you some examples. So everybody obviously has one of these. And I'm sure a lot of you are using these if you have a car or if you ride with your friend's car, using these to navigate yourself around the city. This is your GPS, this is your navigation system. Think of the amount of data that's required just for you to drive around each day and navigate around the city. Another example is, so Taras talked about yesterday when I flew here. So my plane was late, didn't even realize it's going to be late. I come out, and actually Taras' brother Ivan was waiting for me. And I thought he was probably wondering where I am and what happened. I said, no, I got a notification from Google that your plane was delayed. And so I knew I could come a little bit later. So think about that. The fact that he had my flight information, and he got a little notification to his cell phone that said, oh, Carl's flight's delayed. All the data involved with that, just the interconnection between different systems, requires a tremendous amount of data. Or the other one, which we all know very well, is Facebook. Yeah, I just looked earlier today, and there's 1.7 billion people in the world who use Facebook. So how many of you are Facebook users? Raise your hand. Okay, most of you. So think of all the data on there. Think of all the pictures you took of here's what I had for dinner last night. Here's me at the Champions League game of Dynamo Kyiv versus Napoli earlier this week. Had some friends who were there. And think of all that data and the exabytes of data. Also think about the fact that it stores it for years. I don't know if you get this, but it seems like every day recently I've been getting these notifications. Here's a picture that was taken of my son, 5 years ago when he first started playing soccer. Or here's some post I posted, 10 years ago. I think I've been on Facebook for about 10 years. And it's just amazing how it keeps track of this and these notable things, memories from my life that come back up, and Facebook reminds me about that. Again, that's exabytes of data. And then, I think the other thing we should talk about later is the velocity. That quite often what's most important is I need to get this data right now so I can act on it right now. So managing all of that, requires that we have to look at this, how we create the databases, what sort of information we keep in these databases requires a whole new paradigm in terms of how we handle it. And then, as you look at the types of data, So you have user machine generated. We'll talk more about that later. You know, so it's not only the data that's generated from your mobile phone, but it's also, say, for example, data generated from your refrigerator. I don't know if you've seen this, but you have refrigerators that, you know, can, the idea would be in the future, the refrigerator can tell you you're out of milk. You need to get some more milk. Or that, you know, I'm about ready to break down, you need to get the refrigerator repaired. Another one which is big in the United States is so you have your water meter. So if you have, or I'll use the electric meter. Okay, so the electric meter that keeps track of how much energy you've used in your apartment. Then now there are systems where you don't have to have somebody go to your apartment or go to your home and read that meter, but it can be read electronically. And it sends that data back to a central location. You know, that's you know, thousands of megabytes of data when you collect from all the different homes, all different apartments. You know, and being able to analyze that and understand what to do with that data is quite a complicated process. And then, of course, you have just the information you're familiar with from the past. You know, like, for example, what websites you're looking at, what did you search on the websites. You pull out an XML, that's more semi-structured. And then you have the unstructured, which is what we talked about before, you know, from Facebook. And then, of course, you have the whole thing of where do you collect all this? You collect all this in a data center. How do you organize it? How do you retrieve it? And then how do you begin to analyze it? And here you can do a historical analysis in terms of what was I looking at, say, for example, on Facebook last month, or was I looking at Google last month? Or what's becoming more important is what am I looking at right now? Or where am I right now? And this is actually becoming more important, but this requires a lot more processing power. So I'll give you an example. So there is a telecom company that decided that they wanted to, for their most valuable customers, you know, what they call it priority one customers, they wanted to know when they had a drop call. So let's say that you have Yvonne, you know, who's a top customer for this company, that if he's making a phone call and then the phone call drops, they wanted to be able to, within 30 minutes of that happening, be able to contact him and say, yes, we know that you had dropped call, and we're sorry about that, and we're going to go ahead and give you a refund because that dropped call. So imagine all the processing power. They have to be able to track all these different people who are there. First of all, know who your top customers are. Second, know that the phone call was dropped. And then third, be able to contact them and let them know, we know this happened, we're sorry, as well as give them a refund. That requires a lot of processing power, a lot of intelligence. And that's really what they're trying to do here, is they're trying to offer a new service. And the whole goal with that is they want to retain that customer. Because, for example, my phone company in the United States is called Verizon. So Verizon ever contacted me and said, hey, I'm sorry. I know that when you're driving home today, and you called your wife, my wife's name is Yana, and we know the phone call dropped, we're going to give you a $10 credit. Would I want to continue to be a customer of Verizon? Would you want me, if Keith Starr called you and said this, would you want to continue to be a customer? I mean, you'd be surprised, wouldn't you? So this whole idea of how do we retain customers. And then, you know, so and what this drives is revenue growth. Also, there's some cost optimization things that can be done as you just can do more real-time analysis and understand where the costs are, where the revenue opportunities. So I won't talk about this too much, but I think the key thing here is that you have this pyramid that goes up. So you have all your data sets, your structured, your semi-structured, your unstructured. We've talked about that. And then you have to go ahead, on top of that, you have to have to make sure the right people, the people with the right tools, data engineers, data scientists, the right processes, the right systems. And then the most important part is taking these bottom layers of the pyramid. Now you can gain new insights, and you can come up with new business opportunities, as well as offer new experiences for your customers. But the challenge is that with all this, when you have too much data inside, and I'll talk about this later, but one of the challenges been is there's so much data. What do I do with it? How do I analyze it? And how do I gain new insights that will benefit my customers from it? And then the other thing is, you see, we've talked about this, the volume, velocity, and variety. But the other challenge is just the veracity. It's a big word, which means the truthfulness. Because you may be getting data from different sources, and you may find out it doesn't correlate. And so how do you figure out what's the most accurate? So now let's talk about some of the trends, what's driving this. And a big thing which is driving is the Internet, what we call the Internet of Things. Who's heard of that term, the Internet of Things? Okay. And the whole idea here is that you have, as I mentioned before, you have your cell phone. I don't have one of these, but you may have your watch, your smartwatch. You may have more and more of the game with medical devices. So you would have your what they call the Fitbit, which allows you to go ahead and monitor how many steps you've taken each day. I have one here on my phone, which is called the. Let's see if I can show it to some of you. It's called the Pacer. So this Pacer right here, it tells me that I've taken 3,576 steps today. And as you get older, I mean, I'm a little bit older than I look. But as you get older, you find you don't have much time to work out, to go run or go bike. And so I find this is a motivation tool for me to take more steps. But it's amazing for me just how I can walk around and this knows how many steps I've taken. And I found it was actually pretty accurate. But my point is, you have all these devices. I mentioned your refrigerator, your TV. Anything now, the idea is that anything's going to have an internet connection. Anything can send data back. And so the challenge with that is that if you're going to have 50 billion connected devices, you could potentially have up to 2.5 exabytes of data per day. And what do you do with all that data? In the US, they have a good bit. But as you can see in this next slide, the trend is going to be moving more towards more and more towards data growth is going to be outside of the United States. Of course, as we talked about already, Facebook generates a lot of that data. LinkedIn, I don't know how big that is here. Twitter. And so with all that data coming along, and this slide, you can't see, there's supposed to be a blue part here. But anyway, the point is that you're going to see a lot more of this growth happening outside of the United States. Actually, this right here. Here we go. Forecasted data traffic. Most outside the United States. If you look at Central, East, and Eastern Europe, 37% growth here. In the Middle East and Africa, 56% of the growth there. And with all, and the other important thing is that your unstructured data is going to account for 80% of all data by 2020. And the interesting thing with this is If you go back here, 90% of the world's data has been created in the last few years. So again, how do you manage all that? And what do you do with it? I mentioned the whole thing about, the phone company that wanted to know when their priority one customers, when calls drop. There's other companies that are saying, I want to be able to deliver promotions, deliver ads to people when they're in certain locations. Cisco has been working with companies. They developed this thing called this Mobility Services Engine. And the idea here is that I could be in a store. So, for example, what's near downtown, nearby my destination residency, what's the big mall down there?
Globe.
What?
Globe.
Okay, Globus, okay. So I'm in Globus. I'm walking around. And I walk in front of the shoe store. And all of a sudden, I get a promotion delivered to my phone for shoes. Now, how does that happen?
GPS tracking maybe, no?
Yeah, there we go. So the GPS tracking, they also can use Bluetooth beacons. And obviously they're going to have a wireless network in Globus. And they would know exactly where I am. I would walk in front, and they deliver to me a promotion for shoes. Or the other thing they've worked with, this is something that's very interesting for some, for some retail stores in the United States, is they want to know the amount of traffic in different departments. So like for example, it would be very interesting for them to know if, I'll use the shoes example, that if we have a lot of people right now over the shoe department, they'd like to know that so they can have their salespeople move over to the shoe department. Or maybe now they switch over to the men's department. Again, they want to be able to track that data so they can reallocate where their employees are to focus on where the traffic is. Another interesting one that I can share is, so I had worked with a client last year, and one of their customers was a zoo. And this zoo wanted to put in a wireless network. And one of the most interesting things for them was they had this, in certain areas they had like this, think of it as kind of like this cage above ground. So basically like this cylindrical little kind of tube that, and you can see through it, animals can walk through this thing in certain parts of the zoo. And they wanted to give people the ability to say, hey, I'm in this part of the zoo, and I just saw a panda. And they can go ahead and post that on Facebook or whatever. And then information can be sent to other people in the zoo. Say, oh, the pandas are right here. We can come see the pandas. Because for them, it's very important to know where particular animals were at a particular time so that people in the zoo can come and see them. So again, what does this require? This requires GPS tracking or the Bluetooth beacons, requires lots of wireless access points, and of course requires lots of processing to be able to deliver that information, because the panda might only be there for a few minutes and you move on. So again, it's in-time processing sort of thing going on. And with this explosion, as I mentioned, it's happening outside the United States, in places like, sorry, I'm going back. There we go. A lot of it's happening here, which I think is good for those of you who live here in Ukraine. We're seeing a lot of it in Latin America. And the mobile data is driving it. The other big thing that's driving it is the video traffic. As I mentioned before, it's all unstructured. And so tremendous opportunities to build new applications which will allow you to go ahead and provide the real-time analytics, provide that real-time information that people can act on, and provide better experience for the customers. So I'm going to pause here before I get into the technical stuff. So I'm speaking English, and then some of you probably understand well, others not so well. So let me pause and see what questions you may have. Yeah.
In what kind we can use big data in construction? On the next slide you have a chart in the right bottom corner which revenue or profit different areas of human activity.
Yeah.
Yes, in construction. Big
Yeah.
data in construction.
Yeah, okay. Sorry, are you in construction? Is that, okay. Yeah, that is a big one, and I'll talk about that. And I can provide some cases for that. Yeah, we'll talk about construction. And we'll look at different opportunities by industry. Any other questions?
I'm also interested in how using data for example, like medical field, maybe you have some cases for medical
Yeah, I can say so. I don't have anything in the presentation, but I can give you some examples.
Are there available any systems that gather information from whole city?
Excuse me?
Are there available systems that gather information from whole city?
From what?
Whole city. Like Kiev, New York.
Oh, okay. From Kiev?
From Kiev, for example, from New York.
Oh, okay. Yeah, I don't have any examples that are from Ukraine. So,
What about for?
from where?
And what about America?
From America? Yeah. I'll share some more examples. Okay, so the next part, I'm going to go through this quickly because I think for those of you here are scientists, you may know some of this stuff. I'm going to do this quickly because I want to focus more on kind of real life examples. So I think the key thing here is that in a traditional way of processing data and storing it, it was very much focused on we have to get the data, we have to prep it, and we have to put it into the right framework, into the right database, in the right format, and only after we've done that can we really analyze it. The new paradigm here is you can take data, structured, unstructured, semi-structured, you put it into what we call a data lake. And Hadoop is something you may have heard of. It's something used for collecting this data. And the whole idea is you put whatever data you have, put it in this lake, and then you use different tools to analyze the data based on the type of data you use. So here you can have online transactions. Say like for example, from a restaurant and all the data for all the different customers they had. You have machine data. You have from web logs, from click streams, from Facebook. Put in the data lake, and then you analyze it based upon what type of data it is. And what this allows you to do is all the data together, you can find new insights, you can find new connections between the data, which were previously not possible because previously everything was its own little, something we call silo, its own little chemical column, and there's no connection. The company I work at, Cox Communications, their challenge is they have these traditional databases that have information about their customers, and quite often there's no integration between them. They have one set of tools for the business customers, one set of tools for the residential customers, and what they've realized is we need to put this into the data lake just so we can get more integration, get more linkage. Another company, AT&T, they have 19 databases. Massive effort to try to integrate all this information. And in some ways, you almost have to, let's say you have to start over, but you're having to re-engineer their whole methodology for how they look at their data. And Again, it's just the whole idea of using Hadoop as a data refinery, using Hadoop as a place to collect this data, and then make it available for analytical tools, whether it be using something called R or Mahout. Mahout is basically some library of different algorithms, artificial intelligence, and so on. You also have Scoop, Bloom. Yeah, these are pretty interesting names. So these two actually allow you to take the data from traditional databases and transfer it over to the data lake to Hadoop. And then you have some tools for exploration, such as HBase and Giraffe. And then the other tools that would be more the data processing. And these are some of the, I won't go into details on this, some of you may already know this, but like for doing your queries, you have a tool like something called Hive. And it basically uses something that's kind of like SQL to structure and query your data. You also have something called Impala, which uses parallel processing. Again, it's a query engine, but this is doing massive parallel processing, so the performance is much quicker. I mentioned transfer tools, Bloom and Scoop. And then, of course, you have your processing tools, HBase, Giraffe, and then the other ones I mentioned before, R and Mahout. So again, these are some of the tools. I won't spend too much time talking about this. The other thing you see with this is, so with all this data, with all these exabytes, the challenge is, how do I process all of this data? How do I do it in a time frame that's really going to allow me to get value out of this? And the challenge here is what they're saying is we need to do this in memory as opposed to putting it on your disk. And we also need to make sure that as we look at our hardware and software, they get more of a correlation between the software capabilities and design them to meet the hardware limitations. As well as you want to do some of these analytics, do it in the database, as opposed to pulling it out of the database into a separate storage area and then analyzing it. And actually a tool called Hawk, I'll talk about that a little bit. But here is what they're trying to do is they're saying, where is the data right now? Let's analyze it where it resides. Let's process it where it resides. And use that methodology just to speed up the whole process. And here's an example here. So the idea is that, how many of you, by the way, I'll stop here. How many of you know what MapReduce is? Okay. So I'm not going to spend too much time on this, but I think some of this may be, I'll use the term maybe Greek to you. But the whole idea here is that in MapReduce, it's more of a serial process. With Spark, you're introducing more parallel processing capabilities. It speeds up this whole thing and how it happens. It speeds up how you do the analytics. Now, Hawk is one of the tools that allows you to do that. It basically it's parallel processing, SQL type of architecture to basically just speed up this whole process. And so, with this again, the advantage is you're using clusters, you're making it scalable, you're using commodity hardware. If you look at what Facebook and what Google are doing, and this is all off the shelf. I mean, this is all home built. This is all very much commodity hardware. Building their own servers, building their own data centers. It's not getting stuff from EMC or from Cisco. It's parallel processing. And as I mentioned before, it's really the metadata. You're training on the fly. It's very flexible. You assign data structure on an as-needed basis. You don't go ahead and format databases to handle a structured formatted data. You're basically saying, let's collect the data, let's go ahead and structure, format it on the fly, and that way it can accommodate whatever sort of metadata we have. Questions? Yeah, I understand. For a lot of you, this stuff, not that interesting.
Okay, I have a question. Sorry.
Yeah.
For example, your company doesn't have power to process all the information that she gathers. How do you choose which information you process and which you want?
That's a good question.
It's a man-to-man operation.
Yeah, I mean, so with that, that's why you're seeing companies spring up, like, for example, Amazon Web Services. So Amazon is saying, we will rent you, on a per CPU, per hour basis. We'll give you the capability to go ahead and process that data. You have Amazon, you have, I think Google's doing this. So a whole industry is sprung up so that they can go ahead and do that analysis, do that processing for you. Because you may not have the capability, you may not have the CPUs to process that data. Does that answer your question?
Yes.
Okay. Yeah.
The problem with such kind of cloud platform as AWS and Google is that you should firstly at least anticipate how many will it cost for you to pay for each processing unit, as it is well established for Amazon and for Google. So there is a problem. You should know exactly how much of terabytes of data you should at least process for your first time, and after that, of course, you can scale your application as well.
But they actually can help you figure out, based upon what your needs are, they can help you figure out exactly how much you need.
Technical support.
Yeah. Yeah. Okay, so I'm going to get into now the business stuff. The stuff that's probably more interesting. So here's the challenge. So this right here is called the hype cycle. There's a group called Gartner, and Gartner's consulting group. They talk about the fact that with any new technology, there's always kind of a hype cycle. The new technology comes out, and people start thinking it's going to go ahead and change the world. And there's a lot of talk about the possibilities. Many people don't understand it. And what you typically see is that there's growing expectations. Every company starts saying, we're getting into this business. So the first time you heard about it in 2005, where this guy named Roger Mugalis, he came up with the term big data. And then Hadoop was created in 2006. And then in 2008, Cisco started releasing what they call their virtual network index. And they predicted IP traffic would grow and double every 2 years. And then in 2009, big data business intelligence becomes a priority for CIOs. And in 2012, which is probably the peak, was the market for big data software exploded to $4.3 billion. By that time, everybody's saying, I have to have a big data plan. But in 2013, folks started realizing that for every dollar spent on big data, I'm only seeing 50 cents in return. And so people started saying, what is this? I mean, I'm spending all this money on storage. I'm spending all this money on putting everything to a data lake. I'm not really seeing how this is going to change my business. Companies keep on putting money into it. And I think really, probably last year, people started saying, I need to dig a little bit deeper. I need to figure out a little more about how, what data do I need? And what data do my customers need? And how do I use that data to enhance my customer experience? And the other thing you start to see is you start to see a convergence between big data and Internet of Things. And you start to see folks start realizing it's not as much about the data, it's more about the analytics and exactly what I'm doing with this data. And as I mentioned, a large part of what's driving this is what folks like Facebook, GE, and Uber are doing. as they take the data they have, make it available to devices that you have, and allow you to act upon it. So how many of you have heard about Uber? Is there Uber in Ukraine?
Yes.
Okay. How many of you have used Uber? Okay.
Works not so good.
What?
Works not so good in Ukraine.
Not so good?
Yeah. Sometimes it's difficult to get the car.
Okay.
So user experience is
Yeah.
not that good.
Okay. Yeah. So Uber, yeah. I mean, I think in Ukraine, and I'll be quite honest, is that it seems like a taxi here in Kiev is probably a little bit cheaper than, say, a taxi in New York City or in San Francisco. So, but think about Uber. And think about the fact that you can go ahead and have your app on your phone, and you go ahead and say, I'm here, I need a car to pick me up. And isn't it amazing that when the way it's supposed to work, I'm not sure it works that way here, is that there should be multiple drivers who are nearby you and can come pick you up in a few minutes, and it's supposed to be cheaper than if you got a regular taxi. So think about all the data, the processing power involved with it. It's incredible amount of processing power. The other thing is, and I'll talk more about this with GE in a few minutes, is that they're also seeing more and more applications for this in the industrial side. That with GE, what they're realizing is that what GE does is they make engines for airplanes. And they realize that if I can go ahead and take all that data from the engines, if I can process that, and then if I can begin to predict when this particular engine is going to break down and know that ahead of time, that's worth a lot of money. But again, that's that whole convergence between big data and the Internet of Things. So, as they converge, the key things are, this is interesting, but I think this is really interesting. Sensors, all that sensor data. From these engines, they have all sorts of sensors, and they can send data in real time back to GE's database, so you can collect all information about how is that engine performing. The logging, logging from machines. Also, we talked about with Uber, just that, be able to provide that information about the location, where are you based right now, the geospatial, be able to provide, and also social media contacts, provide that information back to the company so they can go ahead and react. They can provide a quarantine real time, or with GE, they can go ahead and they can, in real time, know, okay, this engine, based upon the information I'm getting, is about ready to fail. And so when the plane lands, I need to go ahead and fix this engine. As opposed to the way it's done in the past is every so many thousands of miles, I go ahead and do repair work on this engine, regardless of whether it needs it or not. So where are the opportunities? So I've talked a little bit about transportation with GE. You're also seeing with this whole idea of smart cars, of semi-autonomous vehicles. I'm not sure that they're doing this yet, but Google has a whole fleet of vehicles driving all around the United States. They're working on having their own self-driving car. Tesla has that capability. Ford, they talk about how they're going to have an autonomous vehicle sometime in the future. I am one of the biggest proponents of self-driving vehicles because every day I drive from my house in North Atlanta down to what's called the perimeter, which is kind of like central Atlanta. It takes me an hour to drive. And why is that? Well, it's because people are driving, they're looking at their phone, they're driving, oh, they have an accident. because they're not paying attention. Or, you see it all the time where, the woman, she's putting on her makeup, and, putting her mascara on, not paying attention, hits a car. So I'd rather have computers driving my car than have people who are not paying attention driving the car. Let's think about how much faster the cars will move, how fewer accidents. But with that, there's going to be a whole bunch of data that needs to be transmitted. Because my car needs to know what the car in front of it is doing. It needs to know what the car a mile ahead is doing. All these cars need to be communicating with each other. And that's exabytes of data that need to be transmitted in order for this to happen. Another big area we'll talk about this is with utilities. So I mentioned an example before of you have your electric meter at your apartment or at your house. All that data being transmitted back, so that you know what's going on. And that's data I want to be able to look at because I want to go ahead and control how much money I spend on electricity. I also want to know if I leave home. I'd like to know if I left the lights on. Or I'd like to know if, for example, with my water bill, I'd like to know if I left the water on. I mean, how many of you have, during the summertime, you turn off the water, you turn on the faucet, you leave, you go to the dacha, come back, realize you left the faucet on, and you realize I flooded my apartments, as well as the apartments below me, and then 5 floors below me. How many of you have had that happen, or your parents have had that happen? No one's had that happen? Okay, well, when I lived there, I had a couple friends that had that happen. But wouldn't it be great to be able to look on the internet and know that you've done that? You've let your water, that your water's running. You can look at the water usage. You're like, oh shoot, I forgot to turn the water on. I need to run home and turn the water on. And that would be definitely very, very beneficial. So there's that opportunity. And then healthcare. Healthcare is a big one. To have devices that can monitor your heart rate. I have a friend who's working with a company. They have a device that allows you to monitor cholesterol level, monitor all sorts of other biometric sort of statistics. And it's a device it's like a wristwatch you wear that allows you to monitor this sort of information. Tremendous opportunities there. As well as opportunities with artificial intelligence to begin to monitor and do the analysis of, say, for example, certain, like if people have like a rare kidney disease or something like that, and be able to monitor this different trends within your body of different fluids or of other different physiological parameters, and be able to analyze that and predict, okay, looks like this person is susceptible to this sort of disease, this sort of condition, just by monitoring what's going on with your body. We've talked about this a little bit before in terms of the challenges. As mentioned, it's the infrastructure. All this data, how do I handle it, how do I process it? Another big one, which is probably good, this is a good thing. This is a good thing for all of you who are sitting here, is that there's too few people with deep analytical skills to fill the demand of big data jobs in the United States. And there's probably too few people to fill the demand for the big data jobs that are being created here in the Ukraine. So this is a good problem. Good problem for all of you sitting here if you have an interest in this field. The other one we talked about is the ROI. Is that a lot of money invested, does not get that return. That for on average 55 cents on the dollar for every dollar that's invested. And then the data quality. 39% of marketers say that their data is collected too infrequently or not in real time. Or in this survey, 29% report that their marketing departments have too little data or no customer or consumer data. They may have all this machine data, but this doesn't help them in terms of making real-time decision making. So what do? Where's the value? I think the big thing here is, we've talked about some points, is first of all, you need to figure out, if you're an owner of a company, or if you work for a company, what are your big data needs, and what are your capabilities? And then what data do you possess? And then what are the business models to monetize that data and to extract value from it? And then how does your organizational structure and processes, how do they align with these goals? And then how do you communicate that value across the organization? So I kind of hinted about this part here, is that the biggest opportunity that we're seeing is it's real-time, machine-to-machine data, being able to analyze that in real time, and then respond to that and provide a value to your customers. And here's some examples. So it's predictive analytics. I was talking with somebody from IBM, and they said that their biggest, and this is the end of, this is actually beginning of last year, 2015. They said the biggest opportunities they're seeing right now are in with machine analytics, specifically predictive maintenance. Specifically being able to say, when this big engine, or when this big, so for example, in this building, you have this large boiler. So all the HVAC equipment that runs this building, know when that's going to fail. When this big factory, when all the large machinery there, when that's going to fail. If you can predict that in advance and fix it, as opposed to it breaking down, they said that's where the biggest opportunities are with this predictive maintenance. So example. So you have a power plant. Let's say New York City, okay? And New York City, kind of like other older cities, you have thousands of miles of these power lines all throughout the city. And a lot of them are underground. And some of this stuff is put in back in the 1920s, or even earlier. And how are you going to go ahead and figure out when a power line is going to fail? How do you know that? It's almost impossible. So you start going back and start looking at what's all the historical data. But the problem with historical data is quite often it's written on paper, logs. Some of them may have been put in digitized, some may not. It's records, say, of back in the 1930s, that here in this place in Brooklyn, that we had a power line failure. And then you may look at back in the 1980s, back in the 1990s. You have all this data that's been written down, it's in an unstructured format. How do you analyze that? How do you prioritize? When you have these thousands of miles, New York City, 94,000 miles of cable, and their secondary distribution network. This is the secondary distribution network. So how do you analyze this? What Con Edison, which is a power company, did, they worked with the students from MIT. And what they started doing is they started taking all of these old maintenance records, all this information about these incidents, and they started analyzing them. And they started geocoding them. And they start prioritizing and saying that, you know, if you have a certain number, above a certain number of incidents, then we're going to go ahead and say that's priority one. You know, so like say, if in this area, in this block, if we've had more than, say, 10 incidents in the last 20 years, because that's priority one. Whereas over here, maybe 1 incident in 20 years, that's priority 5. And then they put that in a database. They start using machine learning for you to classify this and rank this. And then what they did was they provided this information to their field technicians who would go out there. And they say, oh yeah, we do actually need to do some upgrades here. But now it's a more targeted approach. And they'll take that, it's a feedback loop, they feed this back in to verify this data is right. And so now they can be more accurate in terms of where they're actually going to go ahead and fix things. As opposed to say, all right, we're doing this area because it's January, we always do this area in January. As opposed to having this more kind of scheduled approach, it's now more reacting to the actual historical data. But realize, what's the significance here? So, 1 second outage for an industrial or digital economy firm, $1,477 per second. That's a lot of money. The annual cost of power outages is $46 billion. So here's another example. This is GE. So GE as a company, they have a product called Predicts. It does predictive maintenance. What GE said was they said that here's our big industries where we compete. Here's the number of maintenance hours annually. Aviation is 205 million. The maintenance labor cost annually is $10 billion. And they said if we can save 1% in terms of fuel costs, or if we can save, I don't have the exact number, but save X percentage in terms of downtime because of the planes being down, and that's a significant savings. Okay. One data point provided was industrial producers suffered 5 to 7% unplanned downtime losses from poor maintenance practices. And so GE's saying is that if I can go ahead and I can fix that engine when it needs to be fixed, as opposed to just doing routine maintenance, to save a lot of money. And let me give you an example. Let's do one you can relate to. So I took my car. I have a Honda Pilot, SUV. I took my wife's car. She has a Toyota Matrix. So I took it into the shop to get the oil change. And the technician said, you know what? You probably need to get your struts and your shock absorbers changed. The struts are basically these little mechanical things that support your suspension. They're saying that's a $1,200 repair cost. And I'm wondering, why would I need to get that done? Well, it turns out this guy said, you need to get this done because your car has so many miles, and the recommendation is so many miles you do this sort of repair work. I won't forget that. So I took it to another mechanic who I trusted. I said, Billy, take a look at this. My struts need to be fixed. He said, no, they don't need to be fixed. The other guy was saying, I need to have these struts fixed because the car is 100,000 miles. 100,000 miles is when you replace your struts. The idea here with this is that GE is saying, if I can go ahead and analyze the engine, analyze the turbine, the power plant, analyze the machinery on the train, and create a digital image of it, I can go ahead and make predictions about when this needs to be fixed. Apart from saying, I should replace it because it has so many miles on it. And here's the concept. What GE has done is they've created what they call a digital twin. So for this airplane engine, they've created a digital twin of it. They take sensor data, feed into a data lake, which goes in the digital twin. And it takes all the information about this engine. How old is it? What conditions is it flown in? What is the experience? What's the repair history on it? And then you have the analytics engine, which basically says, now it's time to fix it. And it's doing this apart from the fact that I've flown this engine so many miles, so it's time to fix it. This is based upon real data, as opposed to just statistical analysis. Huge money in this. Their platform, we mentioned before, Amazon Web Services. They use these analytical tools as well as their version of Hadoop. And then the secret sauce is really their predictivity software. And this tells a little bit more about this. So, real-time analytics, they use a product from a company called Pivotal, called Jetfire. Their DB is something called Greenplum. And of course, it all flows with the Hadoop data lake. But they are, all throughout the world now, Genie's basically saying, okay, I can go ahead and I can provide you this real-time analysis. And as I go back to the business case, huge potential savings. What they're saying is that connected machines could eliminate up to $150 billion in waste. They're saying they can reduce downtime, reduce the cost by 50%. And the other big one here is a $1 billion power plant can save $12 million annually in terms of maintenance costs. Okay, so I'll show you another example. Who knows what UPS is?
Yes.
So UPS, I forget, what were the DHL's companies here? So their whole idea is I send my trucks all throughout the United States. If I go to where these trucks are, if I can go ahead and I can use my real-time analysis of where they are to deploy the most effective routes. If I can go ahead and cut down that engine idle time, if I do the predictive maintenance in terms of their breakdown, I can save lots of money. American Express. What they said, they did this experiment in Australia. They said we have 115 different variables that we can analyze to figure out when a customer is going to go ahead and switch from American Express to Visa. If I can do that, what they said is they can, they believe that 24% of their accounts can be identified that they're going to close. So they can go ahead and do something to keep that customer. Here's one which basically maybe some application for Ukraine. So these trucks right here, and I remember talking to a guy from Cisco who actually was involved in a similar project. These tires, $100,000. This truck can cost up to brand new $3.5 million. 65% of these trucks fail because the operator falls asleep. Because he fell asleep. So, imagine if I could give him glasses, that there's sensors in these glasses. I know when he starts getting sleepy. And so I can, when he starts getting sleepy, I can call him and say, Ivan, prosipaite. The other one that's interesting is if I can put a sensor in this tire, and I can know that when the pressure of the tire starts to reduce, I can keep from having these things explode. Because I have experienced a person that been told when these things explode, it's like 10-6 dynamite going on. Huge explosion, very dangerous, and of course very costly. The challenge here is that you want to reduce the truck downtime. You don't want these tires to explode, You don't want the operator, Yvonne, to fall asleep and crash into the truck, because now you have a $7.5 million problem. But again, this is using this very simple. I mean, these glasses, I mean, it's interesting technology. It's not that expensive. But the ability to be able to monitor where your eyes are going and monitor your this other biometric information, and very accurately pinpoint when this person starts sleeping. I think here's another one. Yes, some application for Ukraine. So 100 million shipping containers circle the globe each year. 5 to 6 million of these containers are processed each day by logistics companies. 10,000 of these containers are lost every year. And there's a lot of companies that ship these out there, and they have, I mean, they're tracking the mode, but they're not tracking what's in the container. And so the idea here is you can take something like this device, you can put it in the container, you can have a wireless network, provide communication, as well as you have your satellite network, provide the wide area communication. You can track where the container is, you can track whether somebody opened it, you can track, you may want to track the temperature, track the humidity. Yeah. Again, this costs money, but if you lose that container, it costs a lot more. So finally, the one you're probably waiting for. So, what are the opportunities? What jobs are there? So I actually pulled this from, I just did a search in Google, big data jobs in Ukraine. So there's a, I don't know all these companies here, but somebody's looking for a Hadoop big data engineer. You have this company right here, EPAM. Looking for a big data solution architect in the deep. And by the way, Taras will have this presentation. But I think the areas you see, and similar to probably what you see with other spheres within IT. So you got your big data architect, the one who's designing the system. You have your data scientist who does the research, does the analysis on this. You have your Hadoop software engineer who creates that data lake. Data quality analyst, the one who's making sure all the data is accurate. Big data business analyst. This is the ones that basically take the requirements, the business requirements, translate those into technical specs. And these areas are becoming more popular as your big data modeler as well as your consumer insights analyst. Consumer insights, they're taking that data, all those data streams, and they say, okay, what actual information is there from this? I'll give you an example of how this was done. So, in the United States in 2012, we had our presidential elections. So, Barack Obama, he realized that my key to get reelected is to get young people to vote for me again. That's how I got elected in 2008. And so he put together a team of big data specialists, and they created a campaign on Facebook as well as other media outlets. Now their whole focus was, how do I get young people to vote for me again? And so he had people with consumer insights, understand what's important to young people, how do I create a campaign to attract? He did, and because of the efforts he did, and many people think that was the key reason why he got reelected. These consumer insights can really have significant impact, not only in the in the business world, but also political. So with that, open up to questions.
Okay, so let us firstly thank for announcement. First, all of you will have a presentation via Facebook. And second one, we have gifts from organizers with the best questions. So please ask for very interesting questions. And just one thing, please say loud, okay?
Not very much service to handle this with data because they have because
Yes. Yeah.
But maybe my question, maybe it's not right, maybe not enough attention paid to the data because it was
Yeah, I mean, yeah, so I think it's a new field, and so there's not as many, you know, the software languages, the technologies are brand new. And so the challenge is there's not too many people who specialize in it. Let's say, for example, if I was looking for somebody who knows SQL, there's hundreds of people who know SQL. But there's not too many people who know a package form. And even with the education, that degrees that are focused on big data, it's fairly new. So a lot of schools don't even have program degrees where you can learn the skills that you need to learn in a big data career. You know, many people are having to learn this on the job or go back and get additional education. So it's still fairly new field, which means lots of opportunities.
because I think that in Ukraine it's quite new.
Yeah.
But I think that maybe in US this is more.
US is still quite new. Yeah, I mean, the company I work at, they're creating their first big data. It's the first time they're actually implementing the new. You know, and this is a technology. Now in Silicon Valley, out in California, yeah, it's different. So, but Silicon Valley moves at a different pace than the rest of the United States and the rest of the world. There's still a lot of. Yes.
During the presentation, I have a question about jobs. During the presentation, you mentioned that big data creates job opportunities like big data architect or big data engineer. But on the other hand, you have situations where, for example, like in New York, like these electricity cables, you develop systems that can say where you have problems or send people there. So it's logical to say that number of these people who are working with these cables will be decreased. So my question is the number of broad jobs like software architect is equal to the number of jobs reduced in other fields?
Oh yeah, well,
maybe you have some thoughts about this.
Yeah. So that's the challenge you're always going to have, is that you're going to have that introducing new technologies, introducing new capabilities can have an impact on, impact other folks. But the thing is that you still need to have the folks who are going out there to make these repairs. It's not going to, they can just be more effective in terms of where they go.
Maybe you see this as a problem. Because maybe a more specific question. You talk about, hopefully you talk about semi-automated cars.
Yeah.
And I know that in America there's during like up to 10, from 5 million to 10 million people driving, like truck drivers, taxi drivers. And what will happen to these people when semi-automated cars will be introduced?
You're right.
A huge number.
You're right. Yeah, I mean that's the challenge. That's the they talked about creative destruction. And unfortunately, what happens is that when we create new technologies, it will displace. But the challenge is this is an opportunity for them to go learn new technologies and maybe go move into another sector. So,
and your sector will introduce this job opportunity?
Potentially, or it may come from another sector. So. that's just the challenge. Like for example, you know, and it's just that's just one of the things that happens in the pace of evolution. Like for example, in the United States, a lot of people used to take trains. Not as many people ride trains anymore. So the people who used to be the train conductors or train engineers, they had to get retrained for new jobs. Yeah, it's just it's kind of one of the challenges as technologies evolve, new jobs are created.
Not always.
Yeah.
I understand you. This was like ordinary pattern from 17th to 18th century when, for example, there was introduced new technologies like in the agriculture sector, but people who lost their jobs moved to factories in the cities. So, like, we don't have wasted people. And what about now? You introduce new technology, but it doesn't create the number of jobs it's delivered.
Yeah, but I think what we've seen though is we've seen new industries involved, new industries created, new opportunities created, and we just have to get trained. But I think that's here's the challenge I'll communicate is that, and you'll all of you will experience this, is that the things you're learning now, you're going to have, it's just constant learning and constant adapting. That what I'm doing now, I wasn't doing this 20 years ago. 20 years ago, I was not in technology, doing something completely different. But, you know, as opportunities were created, I had to go back and get education, and find myself having to learn new things, get new education constantly throughout my career. So, because the challenge is if you don't do that, is you find yourself in a situation where, you know, you don't have a job. And, you know, Taras knows this well. I mean, you had 25 years ago here in this country, you had people who were working, for example, in the defense industry, who were making nuclear weapons.
It was 50 million.
What?
It was 50 million in 1991. Now it's like 40.
Yeah.
So as I see, we have unfortunately much more questions. So please, next question.
Yeah.
I
Yes.
have basically two questions, but they are short. They are very short. The first one is the shortest. When actually it happened that the US became so data-based, I mean the business in the US became so data-based. And the next question is,
I'll answer the first question.
Oh, okay.
When it comes to database, well, that's a hard question to answer. And I think that when you saw the transition to the web, so like for example, you know, in the late 90s, when everything is moving online, everything became digital, that would probably be the time when it first started, like in the late 90s. So, but the big transition happens when you start to see Facebook and Google, so probably like about 10 years ago. You know, and as I mentioned in my presentation, 90% of the data exists today is created over the last 2 years, which I think that's pretty bold statement. But you know, when you look at the amount of data that Facebook generates itself, and now they have 1.7 billion users. It's just going to continue to grow exponentially. But yeah, I would say I didn't answer your question privately.
Okay. And the second one, which data analytics are the most useful in the business consultants here?
Probably consumer analytics.
Okay, thank you.
So please be more precise.
Okay. I wanted to ask your opinion on where you draw the line between collecting the information that you need and respecting the user's privacy, and your opinion on Apple's recent decision to use anonymous information to teach its software, as opposed to Google and collect everything but just promises that it won't use it for something bad.
That's a great question. I mean, you know, it's every person's going to approach this differently. and it depends upon what's being done with my personal data. So I'll give you an example once again. I may have shared this earlier. So I like Georgian food, and and it would have been great if when I arrived here I got a notice about I need to go to Mama Manana to get some Georgian food. But in order to know that I had Georgian food, someone would have to look at an email I sent to a friend of mine about where I wanted to go to dinner last night. That would have to be actually invade my privacy and go into my Google email and be able to analyze that. Now, if there had been that capability to do that, I wouldn't mind. But how about if somebody looked at something I wrote, say for example, if I wrote a political statement, and somebody was able to act upon that because of my political views. I think it's the whole thing of what are people doing with the information that you're sharing. And some folks don't want them to know anything about you. Other folks, are more flexible in what information you know about and what you do with that information. So I'm not sure that really answers your question, but I think it's really more a matter of personal opinion.
Yeah, that's what I asked. That's your opinion. So thank you.
Yeah.
Next question, please. What can you recommend? Self-hosted solution for storing billions of medium-sized charts. I think we're now currently using WeirdFS, but I'm not sure that it's the right solution. I also tried this S2, but it's only paid per version for big clusters. So can you recommend something?
So what sort of files are you talking about?
Not big files, still 1 gigabyte.
Have you ever looked at, have you ever heard of a company called Box? Box.com?
Self-hosted solutions.
What?
Self-hosted.
Self-hosted solutions. Yeah, I got to think about that. That's a good question. I'm not sure. I'll have to, let me think. I'll have to get back to you. I can give you my information. Yes. So you want to do self-hosted, and what type of files would that these be? Like video or?
No, it's all numbers.
Yeah, I'll have to think about that. We can talk after this.
Okay, the next question, please.
Thank you for your report, for the presentation. On one of the slides, there were phrase deep analytical skills. And this phrase describes that people for US labor market.
Yeah.
What did you mean about deep analytical skills? The first question. The second, is it possible to find appropriate and exact metrics of skills which have to know or have to have specialists, for example, data scientists, would have to know, Hadoop engineer would have to know, etc. And the second question, the last question, how much do you study in life per day? How much do you study? You said that you study all the time, and the question, how many do you spend of your time?
Oh, okay. Yeah, okay. So, deep analytical skills is really just being able to use some of these tools for analytics, like for example, R or Mahout. So these are basically like analytical tools for processing data. And I don't know what courses are offered here. What courses do you guys have in terms of big data?
Not for big data, but more for
Business analytics, okay. Yeah, so business analytics classes. No. And it's also really just kind of looking at just the different job postings and looking at what the requirements are of these job postings. So, but I mean, a big one would be just knowing Hadoop. Learn Hadoop. Learn Spark. Learn some of these, these kind of basic tools. And there are online courses. Is Coursera, is that available here?
Yeah.
Yeah.
Okay, the next question, please.
Do you need formal education like PhD maybe in mathematics and so on and so forth to get a job as a data scientist or engineering in the US? Because in many spheres you really do need very huge formal education and it is very when it's done in the US. So is it the case for data science and this?
Yeah, I mean, data scientists typically requires the most formal education, but Hadoop engineer quite often is kind of on-the-job training. I mean, if you can basically say, I've taken the course, I've done these projects, if you can demonstrate, that you have the capability. I think the other big thing is trying to get an internship. Yeah, internship's one of the greatest ways. Like, I don't know if you know Yevgen Vasilev. Does that name ring a bell? No. So
We'll say about him sometime later.
Okay, right, okay.
Please, your question.
So what about privacy? Are we even allowed to use information that we receive or collect from, for example, our customers? And how can we separate the information which we can and can't use?
So each company has a policy about how they do that. And quite often they'll anonymize that. So they'll say, so I know that so-and-so was doing this, had this sort of, basically this kind of search history, or, looked at this information on the internet. I know what they bought, what they looked at, but I don't know, but they don't connect that with who that person is. So you can go ahead and anonymize it so you can see what their patterns are, but not know who that person is.
Okay. Do you have one more question for you, please?
One year wants to have some insight to your business. Do you first have some plan and how to start collecting information? Do you first have some plan or hypothesis and then collect appropriate data, or you just collect everything you possibly can and then you do what you can to
So I think one of the challenges I mentioned, the reason why a lot of companies have not had much success with this is they took the lateral approach. Let's just collect everything. But if you take the first approach of what's my hypothesis, what's my plan, what actions am I trying to get my customers to take, and then collect the data that's tied to that, I think the companies have done that at more success. Because, for example, I used to work with a company that sold smart metering systems. It's the ones that collect the data about the electricity usage and water usage. And we found that our customers, they get all this data from the meters, they don't do the data. But when they start looking at, okay, what data do I need to use? Like, for example, if I'm really interested in letting my customers know if their water is running, while they're going on vacation, what data do I need to provide to that customer so they can go ahead and make that determination? So take the first approach.
The one video Carlet was asked to show, motivating video, and then last 3 questions.
So, remember I asked you the question, what can you do when you have 1 gigabit connection delivered to your phone? This video gives you 5 minutes.
Okay, not very loud, but you can see.
Eric! Nice outfit! Would you look at that?
Self-driving car. Virtual reality.
So guys, this is where I got to today. I mean, obviously we want to get it to the design team's quickly as possible.
Yeah, agreed. Actually, this just came in from them.
Oh, nice.
Not in breaks now. As you can see, things get a bit
Guys,
difficult.
do you mind, something's come up. Do you mind if I jump on the 9:30 call?
Sure.
Intriguing.
This is my picture you made at school today. Oh, your goldfish. And what is their name? Lisa and Snows. It's dark. Oh,
Intriguing.
The universe has a cosmic speed limit. The speed of light. No material object can travel faster than the speed of light. Not even you or me.
Intriguing.
Out of ammo? Sorry, sweetie. What? Who invited you?
She's no secret. What?
Where did you hide? I was in the long house. Good job.
Anyone up for another game?
Okay, begin. 3, 2.
And notice that the grandmother was not there. She was somewhere else. So, that's what you can do when you have 1 gig of information. And that's a lot of things.
The last 3 questions, please. One.
Can I start?
Yes.
During the speech, you mentioned that big data is finding value and finding changes is highest ROI. And
Just take your seats. 5 minutes. 5 minutes more.
can you just name the 5 minutes case for telecommunications?
Telecommunications Street, yeah. So I think it would be
The data is
telecommunications. So I think it would be.
mobile carriers and telecom.
So I mean, I don't know if I named 5, but I think the big thing is churn reduction. How do I keep people from switching? Okay. Another one is in terms of network optimization. Being able to know, understand where am I having issues with my network, where do I need to increase capacity. And those are really and those are the big ones. That's the big churn reduction. Yeah.
The next question, please.
Big data is obviously about a lot of information. And, for example, it mentions the fact what will happen if all this data will be lost. It will cost a lot of money. So the question is, how we can protect our data from losses? For example, hackers, natural disasters, and etc. It will cost a lot of money.
Yeah. Well, that's a great question. That's why they haven't done data centers.
Yes, but what will happen if all the data centers, even under the water, will be destroyed?
There was a TV show in the United States about it. So that's the whole thing of what do you do? I mean, what do you do if there's a national catastrophe and everything's lost? What do you do if there's a war? And what's interesting is sometimes people are saying we need to have a backup. A company I used to work for, Honeywell, they're very much focused on providing microgrid solutions. So you have, like for example, you would have, say, the FDA, Food and Drug Administration. They want to have their own grid, their own electricity source. It's not connected to the rest of the grid around there. And so for example, we had Hurricane Sandy. And when that hurricane happened, so a lot of people lost power. So the MTA did not lose power because they have their own electricity source, their own backup. And so that's what some organizations do. But the challenge is, what do you do if you're, if you don't have all that money? And some people are saying we can go to solar power, or we can have alternative power sources in case the rest of the electricity kicks in. So that's a challenge, and people are thinking about that.
And because the most interesting part of our event, the last one question, please choose one.
My question is a little interconnected with the previous one, but I wanted to ask you, you remember we have all these major leaks from big companies like Sony, and do you think that enough is done in terms of security to prevent the information from going to wrong hands, and like big data can cause big problems? Do you think that's enough time in terms of security?
No.
As you know, ACM is a volunteering organization, and to know about ACM, to few people, you can learn more at our Facebook event page. Please do it. And okay, Carl was in Ukraine in Kyiv some time ago, like a volunteer. Facebook.com/ACM.Ukraine. Here you can find the information about ACM and about the event, about today's event. And now is the most challenging part of our event. So we choose, Carl choose, three most interesting questions. But then ACM Ukraine will choose most interesting questions too. And all take their gifts. So
Okay,
please.
lots of great questions. Lots of great questions. So, but your question, that's a great question, because it's the implication of what you're talking about. So your question about the job stuff. And then about privacy. Where's my guy who asked about privacy? Right here.
About privacy, there was many questions about privacy.
And then your question about the value. Okay.
Okay, so